not. So, what exactly is colorblindness? I don't know. Just kidding! Colorblindness is basically a disorder which results in some individuals either lacking the ability to see certain colors or any at all. You see, there are two cells in our eyes that are responsible for detecting light and color, the rods and the cones. In light, basically, there are all the colors of the rainbow all smushed up into white light. Different objects will reflect a certain color from that light, depending on what color they are. This is where the cones come in, the colorful people. Their job is basically to detect the color from the reflected light of the object. Blue and green cone cells then give the coloring data to the brain, and that, my friends, is how you see color. The more you know. But we still haven't colored the colorful elephant in the room. What? Why does color blindness occur? Yeah, why does it? Well, color blindness occurs when some of the cone cells are either not present, not working, or detect the wrong color. Which basically means individuals with this disorder will see colors in a weird way, or not see any at all. Hopefully not. Believe it or not, there are actually many types of color blindness. Shocking? Yes. Yes it is. One of them is future anomaly. Basically, this type of color blindness will make abnormal green cone cells, which makes certain shades of green appear more red. Okay, that's kind of weird. It's actually quite similar to dog color vision, but it's not the same thing. Another is trianomaly. This one is actually kind of worse than deuteranomaly since it makes the person unable to distinguish between blue and green and also yellow and red. You should imagine living with this. But by far, the worst type of color blindness is monochromy. Being able to see any type of color. So it's like black and white. In fact, 0.01% of the world actually have this color blindness. That kind of sucks actually. I know. I bet you're wondering, how's this disorder even inherited? Well, it's thanks to recessive allele in the X chromosome. If the mother of the child is born with one of the parents having a disorder, then they have a chance to basically carry that allele, that version of the gene, on a 23rd chromosome to be exact, and pass it on to the offspring. But thankfully, girls have a less likely chance of receiving colorblindness disorder, while boys unfortunately have a higher chance, thanks to the requirement of only needing one allele from the X chromosome, because we only have one. Gender discrimination! Moving on, you know, there are actually a couple symptoms of colorblindness, other than the obvious not seeing color thing. Yeah, I know, kind of shocking. Some of them include a stronger sense of smell, enhanced night vision, strong sensitivity to bright light, and even headaches when looking at certain colors. I mean, I get headaches too, but it's not really color related. Okay, well, I'm getting ahead of myself. Okay, I also generally did not expect that many symptoms. Anyway, how did colorblindness make its debut on people's eyes? It all started on a nice Halloween, October 31st, when a guy by the name of John Dalton was basically the first person recorded to have been diagnosed with colorblindness. Man, sucks for him. Basically, he thought the reason he couldn't see color was because of his aqueous humor. Basically, the aqueous substance in your eyes, kind of disgusting, which apparently made him see colors in a different way. Buddy, you were way off. Apparently, there's a common myth where if you're colorblind, you can't see any color. I mean, it is kind of true for monochrony. Like I said earlier about deuteranomaly and trianomaly, they basically say, no. Probably the scariest myth I've ever heard about colorblindness was basically that there's no hope. Once you have it, you're cooked. So an end can't be fixed. It's basically a permanent nerve. Thankfully, this isn't the case because there are glasses that can help correct color vision problems. So don't worry, no hope is lost. Yeah.